Welcome to another episode of Software Explorations, Concept and Overviews, hosted by yours truly, Tech Coach Ralph. In today's episode, we are going to talk about one of my favorite softwares, Docker. All right, so what is Docker? What is it used for? The purpose of it, and all that good stuff. That is what we're going to get into today. But if you haven't done so yet, please subscribe to the channel, hit the notification bell so you can know every time that we go live, and like the video and share it with somebody who will find it useful. All right, so let's get into Docker. All right, so this is going to be maybe at least a two-part series, possibly a three, but we are going to get into the beginning of Docker to find out what it is, what it's used for, all of that good stuff. All right, so let's get started. So, what is our agenda for today? We are going to be talking about what is containerization, why containerization is important, what is Docker, the key components of Docker, what is virtualization, and Docker slash containerization versus virtualization. We're going to talk about Docker architecture, Docker images, Docker containers, and then we will conclude part one for this week. All right, so let's get into it. So, what is containerization, right? Containerization is a technology used in software development that allows applications and their dependencies to be packaged together in a consistent and isolated environment called a container. These containers are lightweight, portable, and provide a consistent runtime environment regardless of the infrastructure they run on, making it easier to develop, deploy, and manage software applications. So that's what containerization is. Like it said, deployment that allows applications and their dependencies to be packaged together. All right. So keep that in mind as we go through this. So why is containerization important? So the important things about containerization, right? And as you start using tools like Docker, you'll find out, you'll see why it's so important. Okay. But it offers portability, consistency, isolation, resource efficiency, rapid deployment, scalability, version control, it works for DevOps in the CI/CD pipeline, and it is important for microservice architecture and ecosystem support. All right. So you may not know what all of these things are, but number one, definitely look it up, research it, find out what it means. And number two, we will get into it as well. Maybe not in this show, but eventually we will. Right. So that brings in what in the world is Docker? So, Docker is a platform and tool chain that enables developers to automate the deployment of applications inside lightweight, portable containers. These containers can run on any machine that has a Docker software installed, regardless of the underlying operating system. Docker provides an abstraction layer and automation of operating system level virtualization, which is commonly known as containerization. So, Docker makes containerization possible, right? You're able to run these applications inside these lightweight portable containers as long as the computer that's being used, the server that's being used, has the Docker software installed. But what are some key components of Docker? So the Docker engine is important. Docker images is another key component. And of course, the Docker containers, the Docker file, if you're creating your own Docker image, the Docker registry, Docker compose, and Docker swarm. So now, what is virtualization though? Virtualization is a technology that allows you to create and manage virtual instances of computer hardware, operating systems, and other resources. It enables multiple environments It enables multiple virtual environments, often referred to as virtual machines, to run on a single physical machine or server. These virtual environments are isolated from each other and from the physical hardware, providing various benefits, including resource optimization, improved security, and greater flexibility. So now, Docker versus virtualization. All right. So the things that when they are compared to each other, we have to take into consideration the isolation level, the resource efficiency, how portable one is compared to the other, security and isolation, and what are the use cases for each. So now we are going to talk about what is the Docker architecture. So part of the Docker architecture contains the Docker client, the Docker daemon, which is the Docker engine, Docker registries, Docker images, Docker containers, and then there's Docker Compose, there's Docker Swarm, Docker networking, and Docker volumes. And we're not going to touch into all of these today, but we do want to give you an oversight of the or an overview of the architecture it takes to make Docker work. So let's get into the Docker images, right? Docker images are the building blocks of Docker containers. They are lightweight, standalone, and executable packages that contain everything needed to run an application, including the code, runtime, system tools, libraries, and environment variables. Docker images serve as a template for creating Docker containers, and they follow a layered and read only file system structure. So when you need to run an application using Docker, it's not the Docker image that the application is running on. The Docker image is just like it says, an image. If you have ever installed an image of a operating system on a computer, then you would see like the image has all the tools installed, all the applications installed, and you install that image onto another computer, which that computer would be serving as a container, and you can use and everything gets installed for you, right? So, like it says, images serve as a template for creating Docker containers. So you don't actually run the application on the container. You don't actually run the application on the image. You use the image to set up the container so you can run your application on the container. So now we get to what are Docker containers. Docker containers are lightweight, isolated, and runnable instances of Docker images. They provide a consistent and reproducible environment for running applications and services. Containers are based on Docker images, which contain all the necessary components, including the application, runtime, libraries, and dependencies. So, and just to add to that, right? So, you can have the same image running on multiple containers, right? So you can set up a container with the same image 5 times and they should work exactly the same, right? You can take the containers and spread them out to 100 different computers, or you take the image and you set it up with the same settings on 100 different computers with the same Docker container, and they should work exactly the same because it is a it's a lightweight, isolated, and runnable instance. So if you were to query each of them, you know, if you make customizations to the container after you start it up, then that's a different story. But out the box, based on the image, you should be able to start up the container, and in all environments, they should be working exactly the same because that's the purpose of Docker images. It's that template. So that concludes part one of our introduction to Docker. We discussed the purpose of Docker, right? And the way that Docker benefits the tech industry is that it allows it allows you to go faster, right? I remember one time when I was trying to learn SQL. So I installed MySQL on this laptop, and that MySQL pretty much took over the whole entire laptop with all the stuff that it has to install. Compared to wanting to learn MySQL today, all I have to do is install the Docker image of MySQL and then start up the container, and then I can log into that container and do all the MySQL stuff that I want, that my heart desires, and then Once I'm done with it, I just turn off Docker and I can delete it if I want to, but it doesn't infiltrate and take over my entire computer. And that's one of the beauties that I find about using Docker. And there's so many other things as well, about using Docker, but that one is one of the ones that always stood out to me, and how it is so quick to spin up new software, new technology, and to be able to get familiar with it without having to go through a whole hassle of an installation process. All right. So how do you get started in Docker? I would say, you know, just install something with Docker. Pull an image and set up the container, right? Maybe something like a Selenium grid, right? Set up the container and log into it, see how it works. You can do a web server, who knows what, right? You can there's so many things you can do with Docker. And my number one advice would be to just get started, do something with Docker, and then you'll have more questions, and then you research those questions and you keep learning and learning and learning, all right? So looking forward to part two. We're going to continue talking about the Docker daemon. We're talking about the Docker volumes, and we're going to, and I will try to show me setting up something in Docker. And if you've followed along in the past, any of the live streams, like I use Docker just about every single show because it just makes it so much easier to get things set up. Part of the Chaos Camp challenges, part of the Chaos Camp challenges, um, we have it set up where you'll build an image and you'll start up that container for the image, and you can go about your business, your work that way. I use Docker all the time when I'm setting up Selenium grids, installing report portals, so many different opportunities to use Docker. And I say, like, that's what we're going to continue finding out about the Docker volumes and networking, all of that good stuff. And I think that it will give you an appreciation for the way that Docker works, the way that I appreciate it, and you will definitely level up and learn more. All right. So that is the plan. So that concludes part one, right? And next week we'll have part two, and we'll continue to learn a little bit more about Docker, and we'll try it out. And if you come across any issues, let me know, and we can investigate that together, and we can maybe help you fix that issue and get on your way. Because I will definitely say that regardless of the industry that you're in the tech field, whether you're in cybersecurity, whether you're in QA, whether you're in data engineering, whether you're in regular web development or software engineering, whatever the case may be, you will use Docker. And the more familiar with it you are, the better off you will be. All right. But on that note, that concludes our episode of Software Explorations, Concepts and Overviews, hosted by yours truly, Tech Coach Ralph. If you have any questions, feel free to reach out to me. If you haven't done so yet, on your way out, please subscribe to the channel, hit the notification bell so you can know every time that we go live, and like and share the video with somebody who will find it useful. But until next time, my friends, family, this is Tech Coach Ralph signing off.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.